And then the number 5 process is random telegraph signal. This definition is based on the semi-random telegraph signal. The definition is yt equals axt, and the xt is the semi-random telegraph signal. And for the parameter a, the probability of a equals 1 equals the probability of a equals minus 1 equals a half. So we can find the first order probability masses of yt equals this. And it is very easy to to prove. We can find the probability of yt equals 1 equals axt equals 1. So this has axt equals 1 has two solutions. The first one is a equals 1 and xt equals 1. And the second is a equals minus 1 and xt equals minus 1. And for the circumstance a equals 1 and xt equals 1, we can find is 1 over 2 times x. The probability of x equals 1 is equals this. And for the second circumstance, the probability equals a half time the probability of xt equals minus 1. And we can find it is equals to 1 over 2. So the probability of yt equals 1 is 1 over 2, and it is similar to the probability of yt equals minus 1. So this is the first order probability masses of random telegraph signal. And the expect equals 0, and the autocorrelation equals e to the power minus 2 lambda, the absolute value of t1 minus t2. And the autocovariance is equals to the autocorrelation function. And number 6, we talk about a random walk. The definition of random walk is very simple. It is tossing a fire coin n times, and k is the number of heads in n tosses. So we can write its first order probability masses here. And we know that from the definition we can find the expect equals 0, and the autocorrelation equals the minimum nm times s square, and the autocovariance equals minimum nm times s square. So from the probability masses, we guess that when n goes to infinity, that means the time you toss the fire goes to infinity, we will have Gaussian density. The autocorrelation function contains a term, the minimum nm, which comes from the property of independent increments. And the last one, we can talk about Wiener process. First, the definition of the Wiener process. The Wiener process is a limit to xt. Xt is random walk, and when t approaches 0, s squared over t approaches alpha and n approaches infinity. And here, this one is the first order density function. And we can find that the mean of this process equals 0, and the autocorrelation function equals the autocovariance function equals the minimum t1, t2 times alpha. And we can find the Wiener process Wt is characterized by some properties. First one, we can find when t equals 0, W0 equals to 0. And second, W has some properties. First, it has independent increments. That means for future increments like Wt plus U minus Wt, U is more than 0. So the value of this are dependent of the past values. And the second, W has Gaussian increments. That means Wt plus U minus Wt. It is like this. With the expect, is normally distributed with mean 0 and variance U. And second, W has continuously path, which means Wt is continuous in T.